Welcome to Brain Vision.
So the question starts off with a 2 kg block being compressed on a spring. We are given that the compression, the amount of compression is 0.22 meters, and the spring constant for this spring is 400 Newton per meter. But what we want to first find is what is the speed of the block as it's moving along the horizontal part, which is this portion, right after it leaves the spring. Now we know that kinetic energy of the block after it's released must be equals to the elastic potential energy of the spring at the start when it was compressed, right? So all the elastic potential energy has been converted into kinetic energy of our block. And elastic potential energy is given as half kx square, where x is the extension or compression of the spring. Equate this to half mv square. We can extract what is the velocity out. So velocity must be equals to kx square over m square root. Right, so this is the expression. So our velocity should get 3.11 meters per second. Next, we want to find how far the block will be able to travel on the slope. Right, so some distance L, which you want to find before it comes to a stop, right, and turns around and fall back down. So how far do we know that it will travel? Right, that depends on the gravitational potential energy that it will gain. Now the gravitational potential energy, mgh, where this is the height, must be equals to the total kinetic energy that it has, or just the elastic potential energy at its start. So it goes to half kx squared. So by finding h, we'll be able to find L by trigonometry. So h is equals to half kx squared over mg, and we know that L is basically h over sine theta, where theta is 37 degrees, and so this is half times kx squared over mg sine theta. Evaluate this and we should get 0.82 meters. Right? So this is our final answer.